Thank you, everyone, and once again, a very warm welcome. My name is Hema Tripathi. I lead the Diversity and Inclusion vertical of People Connect. It's my pleasure now to introduce you to the topic, which is on driving manufacturing excellence through tech, data, and human capital. Now, what does the segment entail? In the pursuit of manufacturing excellence, we recognize the transformative synergy of technology, data, and human capital. This segment will spotlight exemplary practices and real-world applications, how organizations are leveraging these key elements to propel their manufacturing operations towards excellence. I'd like to invite here one of our key presenter from Tata AutoComp, Shunani Srivastava. She is the general manager. I request her to come forth and share the best practices and take us through.
It's still morning. Yes. Good morning, everyone. Thank you for the introduction, Hema, and I'm very heartfelt thank you for having me here. I would like to wholeheartedly appreciate People Connect for this wonderful initiative, SheMaker, and also thank you for making me part of this roundtable today. So I would like to present some best practices our factories and our companies following. It's an automotive manufacturing company, but we are diversifying into various other business and industry verticals like railways, aerospace, and so on and so forth. So before I start off with, with my case studies and presentations, I would like to give a brief about our company, Tata AutoComps. So Tata AutoComps is established in 1995. It has a 28 plus years of experience in automotive component manufacturing. We have 20,000 plus employees, out of which 10,000 plus employees with an average work experience of 8 plus years. In terms of revenue, we are 2.1 billion USD as on FY 23-24. We have 9 joint venture partners. We have 56 plants, 18 joint venture plants, 7 countries manufacturing presence, serving all major manufacturing automotive OEMs and tier 1 suppliers. So this is our footprints, manufacturing footprint all over India. So we have 48 manufacturing facilities, 8 upcoming ones, and 13 different locations in India. Talking about global footprints, we have factories in Sweden, China. So we are talking about global presence. We have footprints in North America, China, and Europe. So these are all the places worldwide we have our manufacturing facilities. Customer portfolio. So we cater to all the segments like passenger vehicle, light commercial vehicles, heavy commercial vehicles, tractors, 2 and 3 wheelers, and industrial and allied industries. And these are all prestigious customers who we serve. Product portfolio, we have we have categorized our product portfolio in various baskets or buckets. EV and electricals, we have 4 companies who are manufacturing components for EV and electricals. Interior and exterior systems, we have 5 different companies who are manufacturing different components for interior and exteriors. Thermal emission and powertrain, we have again 5 companies who is manufacturing components, body and suspension systems, and services. So what are the key success factors which has brought us where we are today? We are successfully running 9 JVs with partners from various regions, North America, Europe, Japan, China. We, as an organization, we are very, very agile, so well equipped to swiftly establish greenfield manufacturing facilities. 40 new facilities created in the last 12 months, 8 upcoming facilities. We have a capacity to embrace and absorb new technologies from various global technology partners. We are well versed with the regulatory approval attainments. That's why we are so agile and we could establish greenfield facilities so quickly. We can manage end-to-end supply chain exceptionally well. throughout over the years of experience. So now talking about manufacturing excellence. At Tata AutoComp, we follow total quality management, and this is what we call House of TQM, which is formulated. This framework has been formulated with our top management's leadership and guidance. The purpose is to achieve the business goals by use of TQM vehicles, tools, and techniques as a foundation of employee involvement, capability building, and Tata values. So you can see at the top of the house is our vision, mission, and then exceeding customer expectation, employee satisfaction, contribution to the society, which is Tata is known for, business objective and strategies. Then we have QMS, EMS, and OHS. And the three pillars of TQM are the TQM technologies, TQM vehicles, TQM principles. So TQM techniques are 7 QC tools, or the 7 QC steps, and we use statistical methods for the problem solving. DMAC we used to deploy earlier, but now we run it through QC story. We have QFD for the new product development, which is like quality for design. QM metrics between product specification and process parameters. And then we have vertical evaluation system to measure the improvements at various steps. TQM vehicles, policy management. This is basically for the improvement management. Policy management is for the breakthrough improvements. Daily work management is for the incremental improvement. Then cross-functional management and quality control circle. TQM principles are, of course, customer centricity, quality focus, and next process is our customers, working with facts and data, enabling people in realize their potential. So these are helping our, Tata AutoComps to achieve the business objectives, which is in alignment to the exceed customer expectation and employee satisfaction, sustainability as per the company's vision. So as you can see, the foundation is total employee involvement. We measure it, we call it 567-100, we'll see in the next slides, and the organization capability and use of ICT. This is unique approach towards excellence in manufacturing to achieve sustainable, predictable, desirable, profitable growth through 5S of safety, 6 sigma, and 7 elimination of 7 losses. This all is done through 100% employee engagement. So we ensure that 100% of our employees are engaged in deploying this approach. So that's why it's 567-100 approach. Manufacturing excellence through 5S. To create safe, the objective is to create safe, hygienic, and feel-good environment for employees, visual controls for operation to find and eliminate abnormalities, to increase creativity, competition in between the employees for increased self-satisfaction and morale. Approach is MSC, Management Systematic Chart, which is Plan, Do, Check, Act. And the actions is we have 5S vision, 5S manual, 5S audit, monitoring, and actions on 5S lead and lag indicators. DWM meeting systems at each levels, monthly abnormality dashboard with improvement projects like number of Kaizen, QCC, etc. Measuring points, checkpoints, cascade to all levels, and then top management review. These are how we deploy excellence through 5S. The effects are, we have recognition from JUSE, CII, and ACMA. These are the glimpses of our, one of our factories, the molding shop, cabin shop, and the SMC shop, and 5S gallery. Improvement management. So challenges are basically, we need to have clarity on what type of improvements to be done and to be done by whom. Alignment of problem-solving tools with category of problems. Involvement of people from all levels. So actions are, through this challenge, how we derive the actions. Identification of problems, solving approach at organization level, 4 levels of employee involvement in improvement projects, worker, line leaders, engineers, manager level, development of improvement, assessment team, rewards and recognition. This is again a framework which we call total employee involvement, and this is prepared for systematic way to engage and measure the employee involvement overall. It has 3 pillars, indicates the various KPIs related to type of employee. The aggregate gives overall percentage of TII, which is measured by each plant on monthly basis. To engage more people, education and training and rewards and recognition system is in place. So you can see the 3 pillars, wherein first pillar talks about the Kaizen management. Here the type is cause and solution are known. Second pillar is quality control circle, where the cause is known but the solution is not known. And then the third pillar is DMAC and QC story. The effects, as you can see, the improvement of employee involvement, which is like Kaizen per person per year is against the target. We are doing very good. We are better than the target. In terms of number of QC circle and percentage of employee involvement, again the graph is very positive. And in terms of total employees involvement, target was vis-a-vis actual, we are doing very well. Second is improvement management is very essential that we eliminate losses. So elimination of losses through value stream mapping. Challenges, as this is one company of ours, which is composite division, and we are into manufacturing of sheet metal components. So one of the challenge was 15 cabs, which was which was not up to the mark, was being produced per the new cabin frame in the manufacturing area. In-house paint shop was a issue. High mold change time and high number of setups in molding was again was detrimental to the overall cycle time. Complexity in product mix and imported raw material. So these were the challenges which we wanted to solve. Actions, the means, what we have defined is PP and PQ metrics, which is product quantity and product price metrics. Classification of components through RRS principle, which is runner, retainer and stranger principle of lean management. Current state VSMs for molding as well as cabin frame manufacturing area. Identification of 7 types of losses, which we call MUDA and MURI in the process. Future state map with implementation of Kaizen burst. So as you can see, the means stated work combination chart to identify the manual and handwork in process. Motion analysis for identification of the losses, MUDA and MURI in the process. This is an example of the line balancing which we did for improvement of the cycle time or the takt time. Resulting, the effects are here, that the manual time reduction in molding as well as in cabin manufacturing. Reduction in number of mold change from 150 to 130 numbers per month, and employee capability development. These are the effects and these are the improvements which happen eventually. Next is digitization. All that we talked about needs to be digitized so that it can be measured effectively. So objective is real-time data capturing to improve the overall equipment efficiency or the availability of the equipments. Data analysis, traceability of part with respect box label for export. Digital monitoring system for Kaizen safety initiative and EBITDA projects. Action was like press-wise overall availability, performance and quality parameters display. QR code poke yoke system for the part traceability with respect to box level. EBITDA portal and tax software for monitoring projects, Kaizens and safety initiatives. So these are the means which were deployed, and effects is like if machine remains idle, that will directly indicate on the screen. Productivity improvement in molding, elimination in wrong labeling for export product, saving monitoring is easier for all EBITDA projects, and tracking for delay and not meeting the target, tracking for Kaizen, safety initiative and safety walk, employee-wise, plant-wise, which increase employee involvement and capability building. So journey has been, by 22-24 we have digitized near miss and Kaizen and EBITDA portal. By 25-27 This is our way forward. We intend to digitize power and fuel monitoring through digitization in MP and CP, measuring point checkpoints, charge placement and control in monitoring, inspection through vision camera. So this all we need to digitize going forward. So quality, customer and internal rejection reduction journey. These graphs are self-explanatory, which shows that 10 ppm target achieved in FY 2024 and 81% reduction in 3 years. Next is 65% reduction in 3 years and 2,500 ppm target achieved in by FY 24. One of the TQM vehicle which we used here is cross-functional management. And the various other tools which we are using as a part of our improvement journey is flag system, which prioritization of customer and component, QA metrics, internal process control through abnormality management, vertical evaluation, prevention of defects at generation stage, DOI, export business by improving paint quality, hypothesis test, statistical validation of alternate PM, AMNOVA plot, projects for reduction in defects at customer end, 2x2 matrix, stability and capability of product specification, and standard do check act, internal rejection reduction through effective DWM approach. Improvement in productivity by cycle time reduction. This is one case which we deployed TQM to improve the productivity and by cycle time reduction is the objective was to increase in spare capacity of utilization at molding so that existing presses can accommodate new product and increase in demand of existing product. Reduction in direct labor cost, which contributes almost 34% of the total variable cost. The actions which we took are classification in molded component as per RRS, runner, repeater and stranger principle, standard work combination chart for identification of auto and manual time, manual time reduction by elimination motion and weighting losses. These are the MUDA losses which was identified and reduced. So as we talked about the means, runner, retainer and stranger, this is the pie chart showing that. So effects, as you can see year on year, cycle time improvement in seconds. Way forward, we would deploy this in mold change time reduction by conversion of internal element to external element, automation in bolt tightening and loosening during mold change process, curing time reduction projects by change in formulation. So how much time do I have? Okay. So I can discuss one elaborate case here, which is actually a real case, which summarizes all the TQM principles we have deployed. So the key focused activity was reduce internal molding rejection ppm from 5,418, which was a baseline for FY21, to 2,500 in FY24, and reduction in internal rejection from 4,782 ppm to 2,850 ppm for Pune molding plant. So as a part of policy, it was decided to reduce the internal rejection ppm from 5,000 to 2,500. This is a breakthrough, so that's why policy change is required. By prioritization, Pune plant was selected for reduction in rejection because in 2023 achieved ppm was 4,782 against target of 4,500. We identified 10 components under high volume and high rejection category out of 63 components. Further prioritization done for the high volume and high ppm components in the coming slides. We can see that. After prioritization of 10 high volume, high ppm category component, the top 6 parts has been identified, which contributes almost 76% of the total ppm. Further, for each top 6 parts, defect-wise Pareto analysis done, in which short fill become the major defect. So pursuing the success scenario, we have started monitoring the ppm in our daily work management of molding plant. shift-wise and machine-wise for all parts, as well as 10 high-volume, high ppm parts for short fill defects. At the same time, we have captured the high volume and the high ppm category parts trend and short fill defect ppm separately, which help us to identify the abnormalities and action taken immediately on the same through SDCA approach. So this is an illustration how we do the DWM. The implementation of the success scenario has happened gradually month-wise, this which is given here. Now illustration for one quality circle project, which was like a limber rear short fill reduction from 12,000 to 2,000 ppm by June 2023. First step, these are the seven steps which I'm going to share in the next few slides. First step was the problem identification. Second is the observation. Identified the actual observation of the strong relationship process parameters from QA matrix. We talked about the QA matrix, which is process parameters and product specification. Through that QA matrix, the identified actual observation was a strong relationship which affecting short fill defect, in which all the strong relation process parameters were as per specification, only mold off stop was abnormal. Mold off stop gap between the pressure pads of mold to ensure tonnage application due to pressure on SMC charge. Mold on stop means no gap between the pressure pads of mold, punch and cavity. So here are the pictures which talk about this short fill. The gap between the two pressure pads were quite high, which was the result of the short fill. Step 3 is the analysis, YY analysis. Y1 was the pressure pad gap is less than 0.3 mm. Y2 was shim found in between pressure pad and surface of mold plate. Y3 was wrong method of shim addition of mold to match the height during double mold loading. And Y4 was the SOP of shim addition in the double mold loading is not adequate. So step 4 is the action, which was before. As you can see, shim of 0.5 mm added, gap is less than 0.1 mm. After the shim was removed, gap restored to 0.3 mm. After this defect was analyzed and corrected, it was monitored continuously for the effectiveness. The result was short fill ppm of limber rear monitored daily and monthly basis. Short fill defect ppm reduced from 12,000 to 0 in March. Step 6 is standardization. So all these steps need to be standardized. Recorded in tool history card. SOP updated for shim addition and removal. Pressure pad gap checking, off stop checking, training provided, and new SOP also created. To conclude, limber rear ejection ppm reduced from 9,000 to 4,000, and though from June onwards, short fill ppm of limber reduced from 12,000 to 0. High volume, high ppm category parts also reduced from 10 to 3. Future plan is QC story project to be taken to reduce the ppm of G45 short hood fill defect. This is the only high volume, high ppm category part still left in top 3 of the highest contributor. So we have prioritized the highest contributors and correcting as a step each and every high contributor. So with this, I would like to conclude, and this is all about what we are practicing in Tata AutoComp and what we are doing going forward, deploying the best practices which we follow in our different plans.
May I request Priya Ranjan Rai from plant manager from Kargil team to do the handover. Thank you so much, Shunali, for sharing the best practices.